All right, let's use another method to solve problem number 3. Like I said in the hint, if you know that 23AB3 is exactly divisible by 99, then you know that 23AB3 has to be divisible by both 9 and 11 because those are factors of 99. So, and if you know your divisibility rules, you know that if this number is divisible by 9, then the sum of the digits has to be a multiple of 9. So we can write that. We can write 2. Oh, wait a minute. That's not what I meant to write. We can write 2 plus 3 plus a plus b plus 3 is equal to some number times n. We'll write it as 9n, where n is an integer. And then using a little algebra, we could subtract 2 and 3 from both sides. So we can get a plus b is equal to 9n minus 8. All right? So whatever those digits are, a and b, they have to satisfy this criteria. So let's take a look at some possibilities for n. So I'm going to write n, and I'm going to write 9n minus 8. And let's take a look at possibilities for n. So if n is 0, we'd plug that in and we'd get a negative 8. And we know that can't work because a and b are both digits in this number here. So that means they have to be single digits and they have to be positive. So there aren't, we couldn't find an a and a b that could give us a negative number. So n can't be 0. We could put in 1, and then we'd have 9 minus 8, which is 1. And there's a limited number of possibilities of a and b that could give us a sum of 1. Basically, a and b, if we write them as an ordered pair, could be 1 and 0, or it could be 0 and 1, right? Those are really the only two possibilities that would work to give us the sum of the digits equal to 1. Let's look at 2. If we plug 2 in, we get 18 minus 8, which is 10. And 10, there's a lot of different possibilities for a and b that would add to 10. We could have 1 and 9. We could have 2 and 8, 3 and 7, and so on. So there's a lot of different possibilities there. If we plug in 3, we get 27 minus 8, which is 19. And if you try to find two digits that add to 19, you can't do it because the biggest digits you could have would be 9 and 9, and that'd be 18. 10 and 9, 10 is not a digit. 10 is a two-digit number, so that's not going to work. So we have our possibilities narrowed down. So now let's look at the other divisibility rule. We know that that number has to be divisible by 11 as well. So in order to be divisible by 11, then 2 minus 3 plus a minus b plus 3 has to be 0 or a multiple of 11. So I'll just write that as 11n. So 0 is a multiple of 11 as well. And again, we can use algebra to rearrange this equation. Now we have a negative 3 here and we have a positive 3. That would just be 0. So we can write this as a minus b is equal to 11n minus 2. And again, we can look at what the possibilities could be for n and narrow down those possibilities. Now in this case, if we plug in 0, we'd get negative 2. And if b is greater than a, then a negative number is possible. So we could put 0 in here, and then we would get negative 2 for 11n minus 2. If we plug in 1, we would get 11 minus 2, which is 9. And there's really only one possibility for digits that would give us a positive 9. A would have to be 9 and B would have to be 0. So this would give us one possibility where A and B were equal to 9 and 0. That's the only one. Okay? If we go on and try 2 for n, you get 22 minus 2, which gives you 20, and there's no digits that we could find that would subtract to 20. So that one's not going to work. We can cross that one out. Alright, so we have our possibilities narrowed down. So let me scroll down a bit here and give us a little more room to work. So let's take a look. At our possibilities here. Okay, so if in this case where we have 1 and 1, or where the digits would add to 1, we'd have 1 or 0 or 1 and 0 or 0 and 1. And neither one of those cases is going to satisfy either of these two for 11, right? Because the difference of these digits are either 1 or negative 1, and that wouldn't satisfy either one of those. So we can't use this one to satisfy both situations. We have to. It has to be divisible by 9, and it has to be divisible by 11. So these possibilities are not. These are not possibilities anymore. Okay, so that leaves us one possibility left here. So we know that the sum of the digits has to be 10. So A plus B equals 10. All right. And if you look at this case, we want if we want the sum of the digits, the difference of the digits to be 9, then A and B would have to be 9 and 0, which is not going to satisfy this condition where the sum of the digits has to be 10. Because if we sum these digits, we get 9. Right, and that wouldn't work. So, again, this isn't a possibility anymore because we can't use that to satisfy both conditions. So, so now we have this one narrowed down as well. So we know the difference of the digits has to be negative 2. So that means A minus B is equal to negative 2. So here's what I'm going to do. I'm going to take these two equations and I'm just going to add them together. Because when I add them together, I get A plus A is 2A. I'd get a positive B minus B, and that's just 0. So we get rid of the B's. And if I take 10 and add a negative 2, I get 8. So that would give us, if we divide both sides by 2, that would give us A is equal to 4. Okay? And since we know that the sum of the digits has to be 10, then I know that B has to be 6. So we get AB is equal to 46. And that's their answer.